KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Neet, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In this class, we start with 51 problem. So this is the last class regarding the dual nature of light chapter and Neet oriented. Okay, right. And students, my request for you is, you will be sent one soft copy to your given mobile number from my side, and if you come to the school means you will get one hard copy also related to this chapter, right? So material no problem. In that material you have both theory and numericals, right? And solution I am telling here, right? Still, if you have any doubts, you can approach towards our through our school facility, right? Either mobile or any WhatsApp, right? That's why nothing to worry about that solutions and any doubts, right? If you want any one particular question, if you approach through proper channel, either WhatsApp or phone, even I can respond and I'll tell you any doubt or any solution, right? So don't bother about that material. I will be provide you, right, a soft copy or hard copy, right? So now we are going to see the first problem, 51. See here. So in this question 51, he is asking, which of the following has the longest de Broglie wavelength? Which of the following has the longest de Broglie wavelength if they are moving with the same velocity? If they are moving with the same velocity. Please try to understand the question first. Which of the following has longest de Broglie wavelength if they are moving with the same velocity, right? Here they have given four things, neutron, proton, alpha particle, beta particle, right? So these four things given as four options like 1, 2, 3, 4 or A, B, C, D, right? I will repeat once again. Which of the following has the longest de Broglie wavelength if they are moving with the same velocity among the following, right? Because already he mentioned which of the following, right? So options I didn't write here, but I am saying. So out of the four, that is what neutron, proton, alpha particle and beta particle, which has the longest de Broglie wavelength, that he is asking, if they are moving with the same velocity, right? Okay. And according to the question, we have to choose the formula. We have to choose the formula. That formula must include wavelength, that is what mass and velocity, because here he is talking about, he is talking about velocity, right? That formula must include velocity, and the question is about to calculate de Broglie wavelength. So here it must be de Broglie wavelength, right? Then by relating these two, we have this relation, that is what lambda is equal to h by mv, right? Okay. So from this we can write like this, that is what lambda is directly proportional to 1 by m. Lambda is directly proportional to 1 by m. Okay, right. Now see here, when lambda is directly proportional to 1 by m or inversely proportional to mass, de Broglie wavelength is inversely proportional to mass, right? So for these four things, whatever they have given as options, neutron, proton, alpha particle, beta particle. We know the relation of mass, that is what you can write like this. M alpha is greater than M and that is what neutron, and this is what MP proton, and this is what M beta particle, right? So this is the relation of massive particles, that is what masses, right? M alpha, Mn, Mp and M beta, right? This is the relation between masses, right? Now, it is inversely proportional, no? Here, it is inversely proportional. So that you can say lambda alpha is less than lambda m is less than lambda p is less than lambda beta, right? So that what can we say? Beta particle has longest de Broglie wavelength because of having less mass. Because of having less mass. To answer this question, if you know that the beta particle has less mass when compared to the neutron, proton and alpha particle, immediately you can get the conclusion according to the question, beta particle has the longest de Broglie wavelength. Okay, right. Next question, 52. See here. Electrons with de Broglie wavelength lambda, fall on the target in an X-ray tube. Okay, right, full stop. The cutoff wavelength of the emitted X-ray is, okay, dash. See here. Let K be the kinetic energy of the incident electron. Its linear momentum P is equal to square root of 2 mk. You can write this one, no? That is what, K is equal to P square by 2m. Right? So that you can write P is equal to square root of 2 mk. Right? See here. We can also have lambda is equal to h by p. This relation we know, right? So this relations whatever we have, I told you, when I was explaining theory, I explained you many times, and even I explained you the formulas list also, right, by writing on the board. That's why, so whenever the relation comes, we have to keep in mind this is the relation we already know and we already discussed, right? See this. We can also have lambda is equal to h by p. Okay, right. When lambda is equal to h by p, you can say that lambda is equal to h by mv also. Okay, right. See this, observe carefully here. When it is lambda is equal to h by p, from this you can write lambda is equal to h by square root of 2 mk. And if you write, k as a subject, you can write it as k is equal to, I didn't write here, but I am saying, right, k is equal to h square by 2m lambda square, right, by writing p value here. And if you write k as a subject, then this one will come, k is equal to h square by 2 by 2m lambda square. Okay, right. K is also equal to hc by lambda. That is what energy, kinetic energy of the incident electron. Okay, hc by lambda naught is equal to k, that is equal to h square by 2m lambda square. That implies lambda naught is equal to, right? That is what, lambda naught is equal to 2mc lambda square. 2mc lambda square divided by h, right? See here, that is what, take this one and this one, right? See, lambda naught into h square will come, no? Right, here square is there, here you see these two things. Here square is there, here no square, so it will get cancelled and 1 h is the remaining, and lambda naught into h is equal, this value will come 2mc lambda square. That is what cross multiplication. Then lambda naught is equal to 2mc lambda square by small h. This is what he is asking. the cutoff wavelength of the emitted X-ray, the cutoff wavelength of the emitted X-ray, right? And this relation we know, this also we know. Just by writing this value here, we are writing K as a subject, then we will get this relation. And already we know this one, that is what K is equal to hc by lambda naught, because K is the energy. K is the energy, right? That is what kinetic energy. And now by equating these two, we are writing lambda naught in terms of the required things, that is what mass, C, wavelength and h. 2 mc lambda square by h. Right, next question 53. See here, lambda p and lambda alpha be the wavelengths of proton and alpha particle of equal kinetic energy, then of equal kinetic energy, right? Then, so they have given 4 options, no? So we have to select which option is correct, right? So, right, you can see in that material you can see 4 options, but you will get this relation, that is what lambda p is equal to 2 into lambda alpha, right? Okay, you just see here how we are getting this relation. You know this formula, that is what even in our previous problem also we discussed, that is what lambda is equal to h by square root of 2 mk. When we are applying this formula for 2 different particles, one is proton, another one is alpha particle. For proton it will be like this. For alpha particle it will be like this, right? And now it is like equation number 1, it is like equation 2. And it's okay, but here you just observe carefully, this is what lambda alpha is equal to h by square root of 2 m alpha into k alpha, right? And this one, what I am saying, this one you can write like this. See how it is possible to write like this. You know, m alpha is equal to, in place of m alpha, you can write 4 mp, right? So mass of alpha particle is 4 times the mass of proton. That's why in case of m alpha, you can write 4 mp, and that 4 comes out of the square root, means 2 will be there, no? That's why, see here, that is what square root of 2 mp and kp, that is what kinetic energy, in place of kinetic energy same, that is what in the question they have given. Proton and alpha particle equal kinetic energy, right? That's why in place of k alpha you can write kp, right? It is equation number 1, it is equation number 2. After that it is mathematical treatment, just you have to divide equation 1 by 2. Then lambda p by lambda alpha is equal to this value. And then h will get cancelled, square root of 2 will get cancelled, mp also will get cancelled, kp also will get cancelled. Then the final answer is lambda p by lambda alpha is equal to 2. Then lambda p is equal to 2 lambda alpha. Lambda p is equal to 2 lambda alpha. This is the relation we have to select from the given options. Right, next question 54. See here. The ratio of wavelengths of proton and deuteron. The ratio of wavelengths of proton and deuteron accelerated through the same potential difference. The ratio of wavelengths of proton and deuteron accelerated through the same potential difference will be, accelerated through the same potential difference will be, right? Dash, see here. So according to the question, what he is asking, ratio of wavelengths of proton and deuteron, but they are accelerating through the same potential difference. Okay, that is the important point we have to keep in mind, right? See here, you know this relation, that is what lambda is equal to square root of 2 qvm, right? And in this formula, no, just in place of k, we are writing q into v. See here, right? So you know that F is equal to EQ, and you know that W is equal to QV, and this is what energy, no? So energy can write in terms of charge and accelerating potential difference, right? So this is the relation we know. Here from this relation, when we are going to go for next step, just to see here, both proton and deuteron have same charge, and according to the question, accelerated through the same potential difference, accelerated through the same potential difference. Okay, then what about this? See here, so this is same and this is also same, and it is a constant. Then you can write like this, no? Lambda is directly proportional to 1 by square root of m. Lambda is directly proportional to 1 by square root of m. Okay, right. Therefore, next step, lambda p by lambda d. So it is what proton and it is what deuteron, right? Lambda p by lambda d is equal to, right? Lambda p by lambda d is equal to, because of inversely proportional, square root of md by mp. So md is equal to 2 mp and it is mp, right? So it is square root of 2. So it is what finally lambda p by lambda d is equal to square root of 2. That only he is asking, no? Just he is asking to find ratio of wavelengths of proton and deuteron, right? So it became as root 2 is to 1. So root 2 means you can write root 2 is to 1, no? Okay? Right. Next question. 55. See this. Lambda E, lambda P, lambda alpha, right? Lambda E, lambda P, lambda alpha are the de Broglie wavelength of electron, proton and alpha particle. Lambda E, lambda P, lambda alpha are the de Broglie wavelength of electron, proton and alpha particle. Full stop. If all are accelerated by same, potential, then, okay, then means what? We have to find the relation among the de Broglie wavelengths of electron, proton and alpha particle. Electron, proton and alpha particle. Okay, right. So first to go for solution, first you have to know the relation. That is what between the de Broglie wavelength and the rest of the things. That is what mass, right, and charge. And according to the question, accelerated potential is same, right? Accelerated potential is same. See the same formula. So whatever the formula we are using here, the same formula we are going to use to this problem also. So when this charge is same and this is same and this is already constant. Sorry. Charge is not same, but this is same and this 2 is constant. That's why we are writing lambda is equal to, just you can write it as lambda is directly proportional to 1 by square root of m cube. 1 by square root of m cube. Okay, right. So lambda E is to lambda P is to lambda alpha is equal to 1 by square root of here me into QE, here MP into QP, here m alpha. See here, so it is what square root, here also square root, and you know that in place of square root of m alpha and q alpha, you can write this, that is what square root of, here 4 mp, here 4 mp, and this is what 2 into qp, or in our words that is what 2 into e, because everywhere here we are writing e and here also e, so in terms of like that means it is 2e will come, right? And now you observe carefully, here you just see this, that is what you just see these terms and this will get cancelled, that is what mp into e, mp into e, mp into e. So here 8 will come, here single 1, like that is what here 1840, square root of 1840, right? Here square root of 1840 and here 1 and here square root of 8. So you can easily say that, no? So what can we say? This is the relation you can say, that is what lambda alpha. See here, okay, I will tell you in adder, that is lambda E is greater than lambda P is greater than lambda alpha. This is the answer what he is expecting, right? According to his expectation, this is the relation you can say lambda E is greater than lambda P is greater than lambda alpha, is greater than lambda alpha. Okay, right. This is what I can say here. Next question, 56. See here. If m is the small m is the mass of an electron and c is the speed of light, the ratio of the wavelength of a photon of energy E to that of electron of the same energy is, to that of the electron of the same energy is. Okay, see here. You know the formula, that is energy of the photon formula, we know, no? E is equal to h nu, that is equal to hc by lambda, right? That's and if you write lambda as a subject, as simple as such, you can write lambda is equal to hc by e. Lambda is equal to hc by e. Okay, right. So here lambda of photon is equal to hc by e, and lambda of electron is also hc by E, okay, but in terms of, that is what, mass and energy, in terms of mass and energy, if you write, then lambda of photon by lambda of electron is equal to, right, this is what lambda of photon, that is hc by E, I already told you. And if you go to write in terms of if you go to write for lambda of electron, it will be square root of, that is, see here, square root of, okay, square root of 2 me, square root of 2 me divided by h, right, square root of 2 me divided by h, okay. See here, so the basic formula is same, that is what, lambda is equal to hc by E, but here for proton it will be like this, and for electron it will be like this, that is for electron h by square root of 2 me, h by square root of 2 me, and it is in denominator now, so if you take into the numerator it will be like this, h will get cancelled, then finally you can write it as c into square root of 2m by E, c into square root of 2m by E. It is the ratio of wavelength of the photon to the wavelength of the electron, right, it is the ratio of the wavelength of the photon and to that of the electron of same energy, right. Next question 57, the de Broglie wavelength is given by, the de Broglie wavelength is given by, right, and you know that formula, lambda is equal to h by p, right, lambda is equal to h by p, right, and the same thing, so the same lambda is equal to h by p, you can write p is equal to h by lambda, p is equal to h by lambda, and this notation h cut is equal to, this notation h cut is equal to h by 2 pi, h cut is equal to h by 2 pi, okay. So finally the de Broglie wavelength is given, p is equal to 2 pi h cut by lambda. So just in place of p is equal to h by lambda, you write in terms of h cut, then p is equal to 2 pi into h cut by lambda, right. It is very simple, just he is asking de Broglie wavelength in terms of h cut and lambda, right. So then I can write, this is what, p is equal to 2 pi into h cut by lambda, right, and if you want you can also say that lambda is equal to 2 pi into h cut by p. Next question 58, an electron of mass me and a proton of mass mp are moving with same speed, then the ratio of their de Broglie wavelength, right. To answer this question, first we have to know the relation between de Broglie wavelength and mass, and you know very well it is what, lambda is equal to h by mv, right, and he is saying that same speed, no, h is already constant, then you can simply say that de Broglie wavelength is inversely proportional to the mass. Then you can write like this, lambda E by lambda P is equal to MP by ME, and this value is, you know, MP value 1.67 into 10 to the power of minus 27 kg, and ME value 9.1 into 10 to the power of minus 31 kg, right. And if you take the ratio of these two things, which is approximately equal to 1836, this is the ratio of de Broglie wavelength of electron to the proton. Next 59, see here, the de Broglie wavelength lambda of an electron accelerated through a potential difference V in volts is, right. So he is asking the formula, right, he is asking the formula, and this formula already we discussed, it will be 1.227 divided by square root of V, okay, that's we already know that. And I already told you, so we have many relations, right, while discussing theory, and the discussions even after completion of theory, once again we discussed at the end. That's why, so when the relation comes, we have to keep in mind, right, every time we need not a proof, okay, right. Next 60th question, if alpha particle, proton and electron move with the same momentum, then their respective de Broglie wavelengths are, right. Here if you observe carefully, he mentioned clearly with the same momentum. You know the formula, that is lambda is equal to h by p. H is already constant, according to the question p is constant. then you can simply say that for all the three particles the de Broglie wavelength is same. So you can write like this ma. Lambda alpha is equal to lambda p is equal to lambda e. Next question, last question from this chapter, dual nature of light, Neet. See here, if the mass of a microscopic particle, as well as its speed becomes half, see here, half, the de Broglie wavelength associated with the particle will be, right? And you know lambda is equal to h by p, that is lambda is inversely proportional to p, that is what lambda is inversely proportional to mv. Then lambda 2 by lambda 1 is equal to m1 v1 by m2 v2, that is equal to m1 v1 by m1 by 2 into v1 by 2. So just this 4 will go to the numerator ma. So this m1 v1 will get cancelled. Finally it is what 4 divided by 1, right? So when it is 4 divided by 1, then you can say that lambda 2 is equal to 4 lambda 1. Lambda 2 is equal to 4 lambda 1, right? So here, which is lambda 2 is equal to 4 lambda 1 is the answer. Okay, that you can say new wavelength is equal to 4 into original wavelength. New wavelength is equal to 4 into original wavelength. Okay, right. So this is all about this class. So in this class we discussed from 51 to 61 problems, right? So in our next class we will start a new chapter for Neet. Okay, thank you.